Welcome to Agentic AI World, your daily interview prep for AI and software engineering roles. I'm your host, and today we're tackling episode 20, AI security and red teaming, how to protect production AI systems. This is one of the most underrated interview topics right now. As AI systems move into production, security vulnerabilities are becoming a critical concern, and interviewers at top companies are starting to probe candidates on this. Let's dive in. Section 1. The new attack surface. Traditional software security focuses on SQL injection, XSS, authentication flaws. AI systems introduce entirely new attack surfaces that most engineers haven't thought about yet. The three biggest threats are prompt injection, data poisoning, and model extraction. Prompt injection is like SQL injection, but for language models. An attacker crafts malicious input designed to override the system prompt or hijack the model's behavior. Imagine a customer service bot that can be tricked into revealing internal pricing or bypassing safety checks, just by how the user phrases their question. There are two flavors: direct injection, where the user talks directly to the model, and indirect injection, where malicious instructions are embedded in external content the model reads, like a document, a web page, or a database record. Indirect injection is actually more dangerous in agentic systems because the agent is autonomously reading content from the internet or your company's knowledge base. The interview question version of this: how would you secure an AI agent that can read files and browse the web? Walk through input sanitization, privilege separation, sandboxed execution, output filtering. Section 2. Data poisoning. Data poisoning attacks target the training data or fine-tuning dataset. The attacker injects a small number of malicious examples that cause the model to behave incorrectly in very specific scenarios, while looking perfectly normal on everything else. This is subtle and hard to detect. Classic scenario: a model fine-tuned on medical data gets a few poisoned examples that cause it to recommend a specific drug, and since it's only 0.1% of training data, your evaluation metrics look fine. Defenses include data provenance tracking, anomaly detection on training data, differential privacy during training, and robust evaluation on adversarial test sets. In interviews, if you're building a fine-tuning pipeline, mention data validation as a first-class concern, not an afterthought. Section 3. Model extraction and inference attacks. Model extraction is when an attacker uses your API to reconstruct a functionally equivalent model, stealing your IP through repeated queries and observing outputs. Defense strategies: rate limiting, output perturbation, watermarking outputs so you can prove theft, and monitoring for suspicious query patterns, like inputs that systematically probe decision boundaries. The related attack is membership inference. Given a data record, can I determine if it was in your training set? This has serious privacy implications. Imagine figuring out which medical records trained a health AI. Defenses: differential privacy in training, output confidence truncation, and model auditing. Section 4. Red teaming in practice. Red teaming is the systematic process of trying to break your own AI system before attackers do. In AI, this has evolved into a structured discipline. The process looks like this. First, define your threat model. Who are the attackers? What are their goals? What's the worst-case scenario? For a customer service bot, maybe it's leaking PI. For a code assistant, maybe it's generating backdoors. Second, build a red team playbook. Document categories of attacks: jailbreaks, prompt injections, adversarial examples, out-of-distribution inputs. Have both automated and human red teamers. Third, automate adversarial testing in CI/CD. Tools like Garrick, PromptBench, and Microsoft's Pyrit can run systematic vulnerability scans as part of your deployment pipeline. Fourth, establish a safety baseline. Clear pass/fail criteria for safety-critical behaviors. The model should never reveal system prompts, never produce certain categories of harmful content, always escalate high-risk requests. The key insight interviewers want to hear: red teaming is not a one-time event. It's continuous, especially as your system evolves and as adversarial techniques improve. Section 5. Designing for defense in depth. Just like traditional security, AI security relies on layered defenses. No single measure is sufficient. Layer 1. Input validation and sanitization. Parse and validate structured inputs strictly. Flag anomalously long or complex prompts. Use a separate classifier to detect injection attempts before they reach your main model. Layer 2. Privilege separation. Your AI should operate with the minimum permissions necessary. If it only needs to read a knowledge base, don't give it write access. If it doesn't need internet access, disable it. This limits blast radius. Layer 3. Output filtering. Before returning any response, run it through a safety classifier. Redact PI, detect policy violations, block dangerous content categories. Layer 4. Monitoring and anomaly detection. Log all inputs and outputs. Build behavioral baselines. Alert on unusual patterns, sudden spikes in refusals, unusual query types, unexpected latency spikes. Layer 5. Human oversight. For high-stakes decisions, always have a human in the loop. AI should recommend, not decide unilaterally, in critical domains. Section 6. Common interview questions on this topic. Let me give you 5 questions you should be ready for. 1. How would you prevent prompt injection in an AI agent that can execute code? Answer. Strict input parsing, sandboxed execution environment, output validation before any action is taken, and principle of least privilege. 2. How do you test an LLM-based system for safety before releasing it? Answer. Structured red teaming, automated adversarial testing with tools like Garrick, evaluation on benchmark datasets, staged rollout with monitoring. 3. A user found a jailbreak that makes your assistant produce harmful content. Walk me through your incident response. Answer. Immediate model patch or guardrail update. Root cause analysis. Update red team playbook. Check if exploit is in the wild. Post-mortem with learnings. 4. How do you balance helpfulness and safety in an AI system? Answer. This is a calibration problem. Overly restrictive models are also harmful because they fail legitimate users. Measure false positive rates on refusals. Tune safety classifiers on real traffic. Maintain separate safety tiers for different contexts. 5. What's the difference between content moderation and AI safety? Content moderation filters harmful outputs. AI safety is broader. It's about ensuring the system behaves as intended, doesn't have misaligned objectives, and doesn't cause harm even through correct behavior. Wrap up. Today we covered the core pillars of AI security: prompt injection, data poisoning, model extraction, red teaming methodologies, and defense in-depth design. The key takeaway: security is not a feature you add later. It's an architectural concern from day one. Engineers who can speak to threat modeling, adversarial testing, and layered defense will stand out in any senior AI interview. Tomorrow we'll cover another critical topic. Until then, keep building, keep securing. This has been Agentic AI World. See you next episode.